No need to worry about the formula now. So we will have some more topic. Ruben will have some more subdivisions related to the same formula. So in that it will be clear. Okay, no need to worry about the formulas. So we'll move to the next topic. One second, wait. I will share the screen. Okay, now the screen is visible. Okay, thank you, Darshan. Thank you. So relationship between torque and rotor bar factor. So anyone tell what is meant by torque? Are you having any idea about torque? What is meant by torque? You can unmute and tell, or you can post in the chat box. You know the power factor. So power factor, rotational force. Torque is rotational force. Okay. Any other answer for torque? Rotational force, it's okay. I agree with the answer. So the torque is considered as a twisting moment of force. Twisting moment of force is called as a torque. So it will be obtained with respect to the force and angular displacement. Okay. So we'll have omega. So the force into omega. So this relates to the torque. Okay. So generally we'll tell that the torque is a twisting moment of the force. So here we are going to discuss about the torque equation. So already you are having some motors. You discussed there is a DC motor, DC shunt motor, series motor. So in that we torque relationship with respect to flux and armature current. So if it is a shunt motor, you will generally will tell that the torque is directly proportional to phi into IA. Phi into IA. So you will tell that. If it is a series motor, you will tell so torque is directly proportional to square of the armature current. Square of the armature current. Okay. So these are the two relationship you already you know. So torque either depends on flux or armature current. And if you equate the torque, suppose you will get some constant. Okay. Suppose so generally you will relate the torque. Torque is directly proportional to phi Ia. And if you are equating these equations, you'll get some constant k into phi Ia. Okay, this is a constant. And similarly, if you relate to the series motor, you will get the torque is directly proportional to Ia squared. So in DC, there is no power factor. There is no we are not supposed to include the power factor in the case of DC. But here we are going to discuss about the AC system. So if we are discussing about the AC system means say AC motor automatically. So we'll include some parameter with respect to this torque equation. So we'll include the power factor cos phi. So that only we are going to discuss. What is the relationship between torque and power factor? And next, we are going to calculate the torque for ideal conditions, standstill and running condition. So what is the difference between standstill and running condition with respect to induction motor? Which parameter will come into the equation during running condition and standstill? What is my standstill means? So the motor is not started. It is in ideal condition. Okay. In ideal condition, what is the parameter absent in the case of induction motor? which parameter will be absent in the case of when the torque is equal to 0 and there is no rotation, then which parameter will be absent means slip will be absent. What is the slip? Slip will be coming to the picture once the motor will start to rotate. Okay. So when the motor is in ideal condition, slip value will be equal to 0. Slip will not be coming to the picture. Okay. When n is equal to 0 means the slip will be at the maximum value. Slip will be at the maximum. It will not come into picture at all. So during the starting condition or standstill condition, the torque equation will not have the slip value. Okay. So during the running condition, we'll have the slip value. So we'll discuss one by one. Okay. So in this we discussed in case of DC motor, so the torque is directly proportional to phi Ia or Ia squared. Okay. Similarly, in the case of induction motor, so the torque will be directly proportional to phi 2 I2 cos phi 2. Okay. So torque is going to be developed in stator or rotor. As per the induction motor, torque is going to be developed in the stator or rotor. Stator la develop rotor la develop rotor. Okay. Sumanthriti. Correct. Okay. So in the stator, we'll have only the rotating magnetic field. We'll have the torque only on the rotor part. So here we are representing all the parameter in terms of 2 or R you can represent, phi R, IR, cos phi R you can represent, or phi 2, I2 cos phi 2. So 1 represents stator, 2 represents rotor. Okay. Either you can, in some book it may be expressed as phi R, IR, cos phi R. So anything you can consider. So the torque is directly proportional to I2, phi 2 cos phi 2. So if you are equating this equation means you will get a constant K. We'll discuss what is my K. K will have small formula, we'll discuss, where K is the constant, phi 2 is the angle between the rotor EMF and current. Okay. So due to short circuited rotor, the EMF is going to be generated on the rotor part. Okay. So that the angle between the rotor EMF and rotor current will call as a phi 2. Okay. So phi 2 represents, if you are not including S means, so it is represented as a starting condition or standstill. Okay. So in this equation, in this torque equation, this is the torque equation as per the induction motor, with reference to the DC. And you know what is my E2? E2 is the rotor EMF. So this is directly proportional to the flux. What is the flux available? It will be directly proportional. So you can replace this phi 2 as E2. Okay. Torque is directly proportional to E2 I2 cos phi 2 because we will have this equation. Rotor EMF is directly proportional to the flux generated or induced on the rotor circuit. So we are replacing this phi 2 as E2. So we are having these two equations only. So first equation we are replacing with respect to E2, and second equation we are having a constant. So instead of having this E2, so we'll have a new constant K1. Here we represent as K, and here we are representing as K1. Okay. And next, so we are going to derive the expression for the starting torque. Okay. So during the starting, okay. So what will be the value of N? So before discussing this, if we consider the slip value, so what is the slip? You know, Ns equal to N divided by Ns into 100. When this N value is equal to 0, so what is the slip value? Slip value will be almost maximum. Okay. Slip value will be almost maximum. So if this N value is going on increasing from 0 to suppose 1470, if it is varying from 0 to 470 means, so what will happen to this slip value means, so this slip value will start to reduce from 1 to 0. Okay. When the slip is equal to 1, so the speed will be 0. When the slip is equal to some 0.1, the speed will be maximum. This is the relationship between the slip and the speed. Okay. So with respect to the starting torque, these are the assumptions. So we'll have E2 is equal to rotor EMF. EMF not the ENF EMF. Rotor EMF per phase at a standstill. Rotor resistance per phase rotor reactance per phase LMA during ideal condition. And you know the impedance, so impedance at the ideal condition will be R2 squared plus X2 squared. So within the root, okay. And these are the basic formula I2 and cos phi 2. You know what is the formula for cos phi? R by Z. So I you can have, what is the formula for I means you can have E by Z. Okay. So you substitute the value. So I2 is equal to E2 divided by Z. And so here you substitute the Z value, impedance value R2 square plus X2 squared. Okay. And next cos phi 2, you know, R by Z, that is everything we are representing in terms of rotor. So you have R2 cos phi 2 is equal to R2 divided by Z2. So that is equal to R2 divided by Z value. So Z value already we are having it here, rotor impedance. And the starting torque will be given as K1 E2 from the previous slide. So this we are taking as a reference. So starting torque is equal to K1 K1 E2 I2 cos phi 2. So you know these values. So you keep K1 E2 here and you substitute the I2 value. This is I2 value and this is the cos phi 2 value. Okay. And simply you substitute the value here. So the starting torque will be equal to, if you simplify, so you will get E2 squared R2 divided by R2 squared plus X2 squared. Okay. So up to this, are you clear? So this will be the starting torque. So from the previous equations, we are simply giving the assumptions, and you know the current value and the cos phi value, and you are substituting the current and cos phi value. Then you will get. You have to remember this equation. So while we are solving the problems, so you should remember this starting torque equation. Then only it's possible to substitute the value, and you can find the starting torque. Okay. Are you clear up to this? Shall we move to the next slide? Manikandan. Manikandan, irgappa 217.
Yes, sir.
Are you clear? Shall we move to the next slide?
Yes, sir.
Okay, thank you. Okay, unmute panikko.
Okay, sir.
Okay, and here we are going to give the K2 as a new constant. So here K1 E2 squared will be K2. So what is the value for? So what is the value for this K2 means from this previous equation, this K1 E2 squared, so will be considered as a K2. Then you will have R2 divided by R2 squared plus H2 squared. So this will be given as Z2 squared, impedance squared, K2 into R2 divided by Z2 squared. And what is the value for K1? So already we have given the common parameter. So this K1 is a 3 phi. So you will have 1 by 2 pi ns. So this is the actual formula. So it is a 3 phase. So we'll have 3 will be included, 2 pi ns. And what is the K2 value means K1 into E2 squared. K1 into E2 squared. So that here we are going to substitute. Okay. So from the previous equation, K1 E2 squared. So K1 E2 squared is K2. Okay. And what is the value of K1? So K1 will be 3 divided by 2 pi ns. So here you refer this equation K1 E2 squared, that is given as K2. Here we are represented as a K2. And this, what is the value of K1? So K1 will be 3 divided by 2 pi ns. And you substitute the value means this will be the final equation for the starting torque. Okay. So this is the final equation for the starting torque. If we expand all the constant, this we are calling as a constant value. Okay. So here you introduce the 3 constants. What are the constants? Generally you will have K, K1, K2. So these are the three constants we included. So we are worrying only about the K1 and K2. So K1 will be this value, K2 will be this value. And you substitute, you will get the final equation for the starting torque. Okay. And you expand all the terms means you will get this final equation. So simplified will be this value, K1 E2 square R2 divided by R2 square plus X2 squared. And you expand with the constants means you will get the starting torque value, this value. Okay. And next, how to calculate the condition for maximum starting torque. Okay. So this is the equation here we are having. And with this equation, so we are taking this equation, starting torque equal to K2 R2 square divided by R2 square plus X2 square. And this equation we are considered. From this equation, we are going to find the maximum starting torque. So here, what is the variable parameter? Okay. So with respect to R, we are going to differentiate this equation. So during the starting period, so the resistance is going to be changed. Okay. So if you can add the external resistance, you can add to the rotor circuit if it is a slip ring induction motor. Okay. Or you can add the resistance in the stator side, there may be change in the rotor value. So with respect to TR, we are resistance, we are going to differentiate this equation. So can you solve this equation and tell the answer? What is the condition for maximum torque? You can apply U by V method and you can tell the answer. What is the condition for maximum torque? If you differentiate this with respect to resistance means you will get the answer. Solve பண்ணி சொல்லு பாப்போம். So in the next slide we will have the answer. Okay. Anyway, you try to solve this equation. So if you differentiate this means what is the answer you are getting? And you can here you can consider this as a U divided by V. And you know the formula. What is this formula? So V squared மேல என்ன இருக்கும்?
U dash V minus V dash U.
U சொல்லு மீனாட்சி சுந்தரம்.
U
நல்ல அஸ்வின் சொல்லு.
U dash V minus V dash U, sir.
எல்லாம் UDV மைனஸ் VDUன்னு சொல்லலாமா?
Yes,
இது
sir.
சொல்லலாமா? இவ்வளவுதான் ஃபார்முலா.
Yes, sir.
நீங்க சொல்லுங்க பாருங்க. You tell the answer. So this is the actual formula. UDV minus VDU divided by V squared. And you try to solve and you post the answer on the chat box. So if you calculated the answer means you can post in the chat box. So this will be the important 2 more question. Write the condition for maximum starting torque. You will get some question in 2 marks like this. Okay. So for that you can write final condition. Final calculate பண்ற பாரு அது மட்டும் எழுதினா கூட போதும்.
சார் பெருசா வருது சார்.
பெருசெல்லாம் வராது, உடனே சால்வ் பண்ணிடலாம். பெருசா வந்தாலும் சால்வ் பண்ணி சொல்லு, என்ன வருதுன்னு சொல்லு ஆன்சர். என்ன பெருசா வரும், ஒண்ணுமே வராது, கேன்சல் ஆயிடுமே எல்லாமே. நல்லா செக் பண்ணு. இது வந்து அப்படியே நீ எழுத வேண்டியதாங்க. ஈக்குவல் டு ஜீரோனா டினாமினேட்டர்லாம் யூ ஹேவ் டு மேக் அஸ் ஜீரோ. டினாமினேட்டர்லாம் ஜீரோ ஆக்கிடலாம் நீ. இப்போ ஹியர் வில் டேக் R2 ஸ்கொயர்டு போர்டில் எழுதுறேன். ஓகே. So what is the starting torque? Starting torque is equal to K2 R2 divided by R2 squared plus X2 squared. So இதில் தான் என்ன பண்ண போறோம், D starting torque divided by dr சொல்லியாச்சு equal to 0. So அப்படின்னா இந்த ஈக்குவேஷன் அப்படியே இருக்கலாம். இது this is constant. You can leave the constant R2 divided by R2 squared plus X2 squared equal to 0. So இதுதான் டிஃபரன்ஷியேட் பண்ண போறோம் with respect to R. ஓகே. ஸோ இங்க டினாமினேட்டர் எடுத்து என்ன வரப்போகுது, R2 squared plus X2 squared இது ஹோல் ஸ்கொயர்ட் ஆகும். ஸோ UdV minus VdU அதெல்லாம் பண்ண போறோம். ஸோ வாட் இஸ் U வேல்யூ R2. ஸோ டிஃபரன்ஷியேட் பண்ணினா என்ன வரப்போகுது, 2 R2 மட்டும்தான் வரும். We are differentiating with respect to R2 minus V value. What is the V value? R2 squared plus X2 squared. Okay. So VdU R2 differentiate பண்ணீங்கன்னா என்ன வரும், 1 தான் வரும். So you write as it is R2 squared plus X2 squared whole squared. This is equal to 0. So இந்த denominator இந்த பக்கம் எடுத்து வந்து 0 ஆயிடும். Numerator மட்டும் சால்வ் பண்ணு. Numerator என்ன இருக்கு, 2R2 squared இருக்கா, என்ன இருக்கு, ஃபர்ஸ்ட் டேர்ம் வந்து 2R2 squared. So this you can make as 0. இது வந்து அப்படியே 0 ஆயிடும். இது அந்த பக்கம் எடுத்துட்டு போனா என்ன ஆயிடும், 0. So what is the term, we'll get 2R2 squared minus R2 squared plus X2 squared equal to 0. ஓகேவா? So இதை செப்பரேட் பண்ணினா என்ன ஆயிடும், R2 squared plus X2 squared equal to 0. So what is the condition? R2 squared equal to X2 squared. So what is the final condition? R2 equal to X2. Okay, rotor resistance equal to rotor reactance. So that is the condition for maximum starting torque. Okay, இதை வந்து சிம்பிளிஃபை பண்ணிக்கணும், டினாமினேட்டர்ல 0 ஆக்கிடணும். So you will have only the numerator. So numeratorல வந்து அந்த காமன் டேர்ம்ஸ்லாம் வந்து சப்ராக்ட் பண்ணிட்டு you can bring that X2 towards the other side. So like this you can solve. So R2 squared plus X2 squared equal to 2R2 squared. எப்படியும் வச்சுக்கலாம். ஓகேவா? So what is the final condition? So we'll get R2 equal to X2. So this is the condition for the maximum starting torque.
சார் 2R2 மட்டும் தான் சார் வரும், ஸ்கொயர் வரும்.
ஸ்கொயர் இல்ல 2R2 into R2 எவ்வளவு, 2R2 into R2 அந்த டேர்ம் பாரு, இதை மல்டிப்ளை பண்ணீங்கன்னா வாட் யூ வில் கெட் 2R2 ஸ்கொயர் தானே வரும். இந்த போர்டில் இருக்கிறது பாரு, ரெண்டுமே ஒண்ணுதான்.
எஸ் சார்.
இங்க வந்து 2 இருக்கு இல்லையா, இது வந்து R2 into 2R2 இல்லையா, ஸோ 2R2 ஸ்கொயர்னு வந்துடும்.
எஸ் சார்.
Then you will get the final equation as R2 equal to X2. So this you can expand as rotor resistance equal to rotor reactance. The VDU minus UDV அப்படின்னு கூட எடுத்தீங்கனாலும் you will get this R2 equal to X2. ஓகேவா? ஸோ இது வரைக்கும் ஏதாவது டவுட் இருக்காப்பா? இதோட ஸ்டாப் பண்ணிக்கலாம். இட்ஸ் ஆல்மோஸ்ட் 3:30 ஆக போகுது.
சார் -x2 வராதா சார்?
புரியல.
R2 equal to -x2 தான் சார் வரும்.
R2 equal to -x2 வராது. ஏன்னா இந்த ஃபார்முலால வந்து VDU minus UDU போட்டுட்டீங்கன்னா கரெக்டா வந்துடும். U by V இருக்கு இல்லையா? இந்த ஃபார்முலா இருக்கு இல்லையா?
எஸ் சார்.
இந்த ஃபார்முலால என்னன்னா நம்ம வந்து
சரி நீங்க போட்டுருக்கீங்க சார், ப்ளஸ் தான் போட்டுருக்கீங்க.
அங்க பிளஸ் தான் போட்டிருக்கேன். ஏன்னா நம்ம இந்த ஃபார்முலா சப்ஸ்டிட் பண்ணிக்கோம். UDV minus VDU divided by V squared சப்ஸ்டிட் பண்ணிக்கோம். இந்த ஃபார்முலா தானே யூஸ் பண்ணிருக்கோம்.
எஸ் சார்.
இது வந்து என்ன பண்ணா VDU minus UDV divided by V squared இந்த ஃபார்முலா யூஸ் பண்ணா you will get that correct answer. ரைட்டா? அந்த மைனஸ் வராது. இந்த ஃபார்முலா யூஸ் பண்ணீங்கன்னா VDU minus UDV but divided by V squared போடு. இதை யூஸ் பண்ண இந்த ஃபார்முலா யூஸ் பண்ணாது. Then you will get correct answer. ஓகேவா? ஸோ அதான் யூஸ் பண்ணிக்கோங்க பாரு. ஸோ இந்த ஸ்லைட்ல வந்து ஸோ திஸ் V squared, திஸ் V வந்து இங்க போட்டாச்சு. அப்புறம் டிஃபரன்ஷியேட் பண்றோம் U-வை. ரைட்டா? அதனால இந்த ஃபார்முலா யூஸ் பண்ணிக்கோம். This will be correct formula. VDU minus UDV divided by V squared. Then that minus will get cancelled. So you will get the R2 equal to X2. சரியா?
எஸ் சார்.
அதான் இந்த ஃபர்ஸ்ட் ஃபார்முலா வந்து செகண்ட் ஃபார்முலா யூஸ் பண்ணிக்கோ. ரைட்டா? அதான் கரெக்டா இருக்கு. கரெக்ட் ஃபார்முலா.
ஓகே சார்.
Then you will get R2 equal to X2 value. So, okay, with this we'll wind up the session. So, we'll continue with this same torque equation. We derived up to starting torque, then we'll move to the running torque equation. Okay, thank you. Nagaraj sir.
Thank you.
So, நீங்க எடுத்துக்கிறீங்களா லேப்? வந்துட்டீங்களா?
Okay sir.